And we are live. So let me share my screen. Great. So good morning, good afternoon, or good evening, depending on where you are. My name is Silvano Coriani. I'm a program manager in the Azure SQL team. And I'm here to talk to you about Azure SQL Database for Python developers. Azure SQL Database is a fully managed PaaS relational database that we have in the Azure platform. It's actually the most popular data services we have in the platform. And the goal for today is to show you how not just traditional Microsoft platform developers can leverage and use Azure SQL DB, but it's actually open to pretty much any programming language and any platform in order to write meaningful data applications based on the relational patterns. So the agenda for today is to go through how in Azure we have this family of SDKs that people can use to manage Azure SQL databases, services, settings, and everything up. And then we will go through the connectivity options we have in our applications, the various libraries and frameworks available. And then, where we can actually host our Python apps in Azure or in any other device to connect to Azure SQL database as a relational backend. And then we will touch briefly on how Python and some Python libraries like, for example, Pandas can be leveraged to do data science, data analysis, exploration of relational data sitting in Azure SQL. The session was originally intended for 1 hour. I'll try to do my best to kind of pack this into 45 minutes, but on some topics you will see me running a little bit faster than usual, right? So what is Python? It's probably need no introductions. Actually, is one of the most popular languages in computing overall. The main characteristic is that this is an interpreted language, is dynamically typed. You can write application using a kind of object-oriented paradigm or imperative paradigm, functional paradigm, doesn't really matter. It's doing automatic kind of memory management like other frameworks, it's Java, .NET, and so on. And it has some kind of very specific kind of syntax requirements, like delimited code blocks and so on, right? But what is more important is that as of last year, actually, Stack Overflow issued this survey, and Python is by far the kind of most wanted kind of language that developers are looking for, right? So it is very important for us as a cloud platform to provide full support for Python developers across all the different services, right? And those scenarios specifically for Azure SQL Database are around, how to manage deployments and instances of our relational databases through, scripting, in your CI/CD pipelines, how to automate things using Python and such, right? Then we have, the application, how we design and implement data-centric applications that are leveraging Azure SQL Database, maybe together with other data services in the platform, like blob storage and such, in order to build our own apps, like our backend REST APIs, our web apps, or microservices-based applications that we may want to deploy on our cloud platform. And then, the last scenario that I was touching briefly is this data science one, where we can do data exploration, for example, data cleansing, importing and such, or do some interactive exploration or any other kind of activity that we can do within Python notebooks, right? Which is a really popular and actually rising in popularity way of interacting with data sources from a data science perspective. So let's start from the first scenario, how we manage our resources, including deployments, or modifications and so on. Right. In Azure, generally speaking, we have different ways of creating and managing our resources. First of all, the Azure portal, web-based, multi-platform. You can use it from pretty much every device that has a internet connection. But as a developers and system engineers, we typically want to script tasks, management tasks and such. So we have a command line interface. It's a library actually written in Python, which is offering all the capabilities that we are using through the portal. It's actually invoking a layer of backend REST APIs, but the commands are the most intuitive ones, like what is the object or the service we are interacting with, and then the verbs. We want to, for example, create a new database or modify a setting in the database and so on. For those that are deploying more complex resources, we also have templates. Templates are JSON files where we are describing, let's say, an entire application, including our application servers, our backend databases, settings, and so on. And we can actually deploy as a single click into the cloud platform, right? Very simple and straightforward, very powerful tools, again, to simplify our deployment practices. We do have other languages like PowerShell and such in order to interact with Azure resources. But as I was saying, behind the scenes, we have this layer of REST APIs that we could interact with some standard tools like curl, for example, in order to execute HTTP requests, pat get and pat type of verbs and so on. Or for developers that wants to create applications, we do have SDKs, right? Those are libraries that are modeled around the services that we have in the backend and are hiding the complexity of interacting directly with REST APIs for you, right? So those are dealing with authentication, dealing with how to interpret kind of responses from services and so on and so forth. So very straightforward way for developers to create applications that are going to manage our cloud resources. And for Python, we have this set of libraries. Those are broken up into a number of libraries, one for each service. So you don't necessarily need to import everything, even if you are not using a particular service. And for each of these services, you have basically a client tool, a client class, which is helpful to actually interact with these services, right? You can find the Azure SDK for Python at this GitHub repo here, so you can take a look at what's going on. But honestly, to simplify, at the very minimum, what you need to do, you need to actually, again, install a couple of packages here, right? So this Azure Common, which is containing stuff like authentication classes and stuff like that, and then this Azure Management SQL, which is the core of Azure SQL libraries, and a generic Azure Management resource, which again is containing some kind of common resources across the platform. And then what you need to do in your code is basically get a reference of this SQL Management Client class from the factory, and then you can interact with all the entities that are exposed in the SDKs, like servers, right? So servers are where we are storing metadata like our credentials and stuff like that. And then each server has a number of databases associated. Databases and servers may have other attributes like firewall rules if you want to block traffic from other sources that are not the ones where our application is running, and so on. There are literally a ton of these classes available to interact, right? But as I was saying, at the end, what we do is we get basically credentials for interacting with the service, and again, we can get it from various sources. In this case, this get client from CLI profile is basically using the credentials I have stored in my profile for my command line interface tool, and then I'm starting to interact basically with the service. First of all, I need to create what is called a resource group, which is a container of all my Azure services or service instance that I'm creating, and then I'm effectively getting the SQL client reference here, and from there, what I'm doing, I'm just starting to create, for example, a brand new server with a certain kind of login and password, and then I can create one or more databases, and then I can configure those databases and so on and so forth. Right, so that's the typical pattern we have, and I do have a simple demo here. So I'm running, first of all, just a quick note on this. So I'm running all these demos in my WSL. This is the Windows subsystem for Linux. So everything is cross-platform here. And of course can run everywhere, Mac, Windows, Linux, and such. For I just like to use WSL on my machine because I can also, for example, open these Windows folders using my VS Code from my Windows machine, and this is connected to my WSL system here. So effectively, I'm running code and I'm debugging code in my Linux box, which is on the same kind of Windows box that I have here for simplicity. And then I can interact with all my demos and services, right? So when I'm, for example, when I'm opening files, this is actually the Linux file system that I have on my WSL deployment here, which is on Ubuntu 18.04, and then I can do whatever kind of developing task that I need to do, right? So what I'm showing you here, those are a number of samples that I just have here, but the example that I wanted to show you is what I had on the slide exactly. So first of all, what I'm doing here, because I don't want to store credentials in my scripts, I'm using Key Vault, which is our secret management service within the Azure platform, where I can store all the credentials. I can, in a secure way, behind the scenes, this is backed by an HSM module, right? So it's stored in a very secure mode. And then, I'm basically retrieving those secrets from my Key Vault, and then I'm using those secrets as I'm interacting. I'm creating resources within my system, right? So basically, what the script is doing is, as I was saying, is creating my resource group first, and then is deploying my SQL Server and my SQL databases, and then is configuring the firewall rules so that I can connect. Right? So from my Visual Studio Code, I can run debug here, and the script we start running in the system. I can of course I can set breakpoints, I can do step-by-step debugging, and so on a Python script which is running on my Ubuntu instance, running in WSL, in Windows Subsystem for Linux, from my Windows machine, right? So this is a very handful type mode of kind of developing cross-platform in the entire application, right? So again, I can run this, and behind the scenes, the application will get basically the database server will get actually deployed, and I need to set my password here, and again, this will basically start doing the work, and this is a way we are actually debugging our deployment scripts through the SDK, which is simplifying. As you can see, I don't need to deal with any kind of REST API. I can use high-level classes in order to do the job, and these are managing, the request responses, requests and responses from the service for me. And this is a very kind of handful way of managing resources in the platform. I can find all type of SDKs, as I was saying in GitHub. Those are actually open sourced, so you can take a look at how they are developed. You see each language has its own SDK. We have it for, of course, for .NET, but for Java, Python, Go, and a bunch of other SDKs that are available for you to start interacting with Azure resources, right? So far, I only touched how we can deploy, manage, delete Azure resources, and specifically Azure SQL database resources with our Python scripts. But I haven't yet touched on how I can connect to my database, which is actually the subject of my next session here. So for Azure SQL, and generally speaking, for all kind of SQL Server flavors that are in the market, including traditional on-premises boxes and SQL Server hosted in other clouds, or the various PaaS platforms and offers we have in the Azure platform, we have a bunch of connectors or client drivers that we offer, right? And those connectors, those base connectors, are based on standard technologies like, for example, ODBC, JDBC. In .NET, we have native .NET libraries for that. And then we may have higher level libraries that are, for example, simplifying the work for application developers. We have ORM tools like Entity Framework. In Python, for example, we do have support for ORMs like SQL Alchemy or Django, and those are actually built on top of other libraries. So in particular, the stack we have for Python developers is based on the ODBC driver, which is a cross-platform. It runs on Windows, Linux, Mac, and it is up to date with all the new capabilities that we typically expose in the SQL Server engine that is powering all these different solutions, and is speaking this TDS protocol, which is it's an open protocol, actually documented, that is basically the dialect that SQL Server engine uses to communicate with clients, right? And on top of the ODBC driver, we are actually supporting PyODBC as the DB API standard in connecting with relational databases from Python. And because of that, we can use Azure SQL database from frameworks and libraries like SQL Alchemy without any particular change, right? So as I said, PyODBC is basically officially supported by Microsoft engineers, right? So we have engineers that are dedicated to provide support here. Is basically integrated with other Python famous or popular choices like Jupyter Notebooks, for example. So we can connect to Azure SQL database or to all the other flavors from Jupyter Notebooks hosted in Azure or hosted in everywhere else, and in a very kind of simple fashion, right? This is based on, as we said, Python DB APIs, which is a standard programming interface, which is basically exposing two main objects and abstractions, right? The connection object, which is, of course, dealing with everything, authenticating, connecting with the database and executing commands. And then we have the cursor object, which is basically created from the connection and is basically giving us the ability to manipulate, retrieve, parse, and consume data, right? And we have the three methods that we have to consume a database is typically fetch one when we are doing point lookup queries, fetch many, where we can get a range of data out of our database, and fetch all, which is retrieving the entire object, if it's a table or a view or whatever, right? So how we use those abstractions. So first of all, we need to open a connection, and we use the connect method of the PyODBC package in order to do that. We need to pass a connection string. We need to specify, for example, server name, database name, and the credentials. Credentials can be defined within Azure SQL or can be defined in Azure Active Directory, doesn't really matter. And then, we obtain a cursor and we define our queries, SQL queries, we execute the cursor, and we can retrieve, the data. And then once we have the rows in a array or a collection, we can just iterate across the collection and do whatever we like, right? In this case, I'm just returning back as a JSON array the results that I have in my rows. Of course, we can also manipulate data into the database, right? So once we connect to the database, we can again get our cursor object, and then we can define our command. A command can contain a T-SQL, so a SQL statement can contain the name of a storage procedure or a view, and then we can pass all the parameters and execute. We can also do transaction management, doing commit or abort, and in a fully kind of transactional manner. And then at the end, we can close the connection in order to return it into the connection pool, which is enabled in the ODBC driver on the line, and then connections will be released. What is very important, generally speaking, when you're interacting with databases, but more specifically when you're interacting with databases in the cloud, is to make sure, for example, that if you have a lot of what we call singleton commands, like, for example, this insert command, and you want, for example, to insert 100 rows or 10,000 rows or whatsoever, that you keep in mind that latency between your application code and the database is really impactful for the performance of your application. So using things like batching, and in Python and PyODBC, we have this execute many option, method, and the fast execute many attributes. This is basically what this attribute is doing, is basically packing multiple statements together in a single round trip with the database. And this is saving you typically a lot of time in interacting with the database. And again, if you have a lot of data to insert, this is definitely a preferred way to go, where you are again passing a bunch of commands and executing those commands as a single operation in the backend. You could do that in a storage procedure if you like. So if you want to write code which is running on the server, these storage procedures are definitely the best way to go. But if you don't like storage procedure and you want to keep your SQL statements in your Python code, keep in mind, especially if you have a lot of these small interactions with the database, that leveraging batching is probably the best kind of performance option you have in the system, right? And let me go back to my demos here, where I can show you a very simple, probably the simplest way of interacting with my Azure SQL database. I have a Flask application here where I'm defining a couple of REST APIs. This is just kind of selecting the top 5 orders in my orders tables, and I'm joining this together with the customers table, so I can do kind of join and so on, and then I'm returning those rows back to the client application as a JSON array, right? So let's see if I can debug this properly. Okay, so let me. Okay, as you can see, what I'm doing here, I'm just retrieving this JSON array with my top 5 orders that are containing data from my orders table and from my customers table, right? So again, this is probably the simplest way of writing code against the database, defining a cursor, executing my command, fetching the results, fetching all the results in this case because I know how many records are coming back, and then consuming the rows with this for loop, and then just retrieving as a JSON, right? Sometimes we don't want to write all this kind of plumbing code ourselves, right? What we want to do is to use a higher level library, as I was saying. SQL Alchemy is definitely one of them, and but let me first to kind of introduce what these libraries can do, and then we can go back to the demo, right? So those libraries typically are providing higher level abstractions, right? So I don't need to deal with basic, opening a connection, writing, down a SQL command, and so on. And SQL Alchemy is a good example. It comes with basically two layers. One is the core layer, which is simplifying how we write data access code. Reddit, for example, the Reddit website is using a lot the SQL Alchemy Core library behind the scenes. Or we may have a full object relational mappers where we take the objects that we are declaring in our Python code, and the library is writing for us the equivalent SQL commands to interact with the database, right? So those are a lot of customers really don't want to deal with the SQL commands in their code. So this is definitely a good option for reducing the complexity in our data access code. Keep in mind that especially when you're entering into very complex and kind of mission critical application scenarios, you may want to control your SQL, the SQL which is generated by those libraries carefully, because like any other abstraction, it may not be 100% perfect in all the scenarios, and it can generate suboptimal SQL code, which in this case you may want to customize with some very kind of custom written queries, and typically this is helping in overall kind of performance management, right? Django ORM is another popular object relational mapper for Python. Is part of the overall kind of Django web framework. Again, it works well. The ORM portion of Django works well if you don't have a lot of complexity in our database operations. Otherwise, again, what you can do is to leverage custom queries, custom written queries, where the performance path of your application is more critical. And the way those libraries are written are very, very simple. And typically they are all have pretty much the same architecture. So underline, there are kind of libraries that are dealing with the backend connectivity, typically based on DB APIs like ODBC that I was describing. Then we have a layer which is where you are effectively abstracting the dialect of each database, and they are exposing higher level expressions to the upper layers of the solution, like the object relational mapper layer. This is where effectively you can define mapping between your objects in the application and your tables or schemas in the database, and then they are managing the creation of the of this kind of SQL dynamic SQL for you, right? So if we use, for example, SQL Alchemy Core layer, the way we are going to do writing our code is we typically define the metadata layer where, for example, we describe what are our tables and columns in the relational data. This case, I have the orders and I have the customers tables. And then what we can do is we can effectively write SQL-like queries that are, as you can see here, are completely abstracting you from the specific dialect that SQL Server or Azure SQL Database is using, and is giving you the ability to write your SQL-like queries that are dealing with the backend database. You can express things like joins, for example, between tables and stuff like that in a completely abstracted language that can work with any database, any SQL database behind the scenes, right? Of course, this is going to leverage the kind of minimum common denominator across these different database services, but it works in abstracting the details of how to deal with the database. Now let's switch to the higher level layer, the ORM layer, because this is what a lot of customers are actually wants to do, right? So in addition to what we have been doing with the core layer, what we do here is to actually model our classes within our Python application. In this case, we effectively create a class model within our Python app, which is behind the scenes, is referring to the backend, database model, of course. And what we are indicating here is, what are our table names, schemas, what are the how the columns are effectively mapping to our objects and our attributes in the application space, right? And once we have defined this model, we can then refer the model and execute queries and access our objects as they are regular objects, in memory in our application. And what's going on behind the scenes is that this kind of SQL query will get completely kind of automatically generated for us, and the results will basically get back to our applications in a relational mode, right? So this is exactly the example that I was showing you before. We create the model. Typically, the model is defined once and then used across the board in our applications. And once we have defined this, as I said, we can use the model. In this case, what I'm doing is I'm getting one particular order ID, and I'm retrieving the order ID as a JSON object, right? So if I go back here to my running code, and I do order and then \1, for example, I'm retrieving the order number 1. Here it is. And by the way, what I'm doing here is slightly different from what we were seeing before, because here I'm joining my order header, which contains these attributes, the customer ID, with the order lines, right? So this is a collection of order line items that I have. And if I look at my debugging window here, I can effectively see what is because I set the logging option on, we can see that effectively the query that is generating is managing the join for me, is doing a left outer join, because that's how we described our relationships between the two tables here, and is passing, the parameter. So it's creating a parameterized query effectively here, and is executing, is dealing with the complexity of this query for me, right? So that if I, for example, here say I want my order number 16, which has only one order line, we can see that the query is exactly the same, but we have a different parameter value here for our workflows in the query, right? So again, this is a very popular way of interacting with the database, typically quite effective if your model is designed correctly in terms of dynamic SQL generation. You just need to make sure that you know what's going on behind the scenes by, for example, turning on logging and see the SQL query generated, right? And there are a lot of options available in these ORM models on how to control, for example, the mappings between columns, how we do the relationships between different tables that have like foreign keys and such, and how we want to load those dependent objects, right, as part of our object hierarchy in the application memory. What is also important to understand, and I think I can show you here in the code directly. So those applications here may have a lot of configurations. One important to keep in mind is this particular example that I'm showing you here is a REST API, right? So we will never, in a single request, typically read data from the database, do some modifications in application memory, and then persist the data back to the database. We will probably have a different API, which is accepting a post command and is taking the post command and is persisting the data. SQL Alchemy by default is doing what is called tracking modifications to the in-memory objects, right? So basically, whenever I'm loading objects from the database into the application memory, it keeps track of if we are modifying values in memory, and then those basically modified values can be persisted automatically in the database. But this comes with a cost, right? Because we need to track all these modifications in memory and maybe keep multiple values that we have been modifying before persisting. So switching off this track modification is very important for performance. So if we have a read-only API, right, or typically we don't need to track these modifications because we are managing changes in a different way, keep in mind to do this setting to false, because this will save you a lot of performance in both the way we are interacting with the database and how the application itself is performing in memory, right? So this is just a kind of a quick recommendation. Another interesting feature that you have available in these ORM tools is dealing with migrations, right? So you can potentially generate the entire schema of your database dynamically based on the objects that you have in the application. And then the moment you are modifying your applications and you are creating multiple versions of your application, you can actually, through some specific commands, like, for example, flash migrate, you can execute data definition language of operations, so change the schema of the application completely automatically, right? So this is, again, needs to be considered as part of your CI/CD pipelines, but it's a very powerful way of focusing on the application code and forget a little bit about database details, because those will be managed for you by these ORM tools. Okay, let's move one step further, right? So where we are going to host these data-centric applications written in Python that are interacting with the database and are hosted somewhere, right? So first of all, from an application model perspective, using Python, we can define things like, again, REST APIs, as we were seeing previously. We could define GraphQL applications, right, by leveraging other libraries that are changing the way the front end is actually accepting query requests. And then behind the scenes, again, we can use SQL Alchemy or other libraries to interact with the database. Our applications could be made of a number of microservices that could be composed as part of our overall solution, and so on, right? So in Azure, we actually have multiple hosting options where we can host Python code. Azure Functions is probably the simplest way. It's a serverless platform where we can take our code and simply our Python code and deploy it in a very simple way. I will show you later an example. And we can write for example, REST API front ends or whatever kind of HTTP front ends we are creating. We could write kind of backend services that are monitoring, for example, a queue, or is monitoring our database, for example, tables, and are doing some backend job type of work, and so on. Azure Functions are very, very powerful serverless tool that we have in the platform. But you may want to create a traditional web app, or you may want to create a machine learning job, right, and host that in Azure Machine Learning service, which is giving you all the ability to run your predictions and to train your ML models. You can run the Python code within Azure SQL. In the managed instance flavor, you can actually load Python code within your database if you have a very data-centric task to execute, for example, for machine learning purpose and such. We have another service called Azure Synapse Analytics, where you can leverage Spark through Python scripts and do whatever data engineering and processing task that you have. Or we also have Azure Databricks as a hosted Databricks and fully managed Databricks engine within Azure SQL for, again, Spark processing in the analytical space. So all these different options are available. I'm going to start from the simplest one, and I'm opening up an Azure function example here, which behind the scenes from a database perspective is doing exactly what the other examples were doing. So let me go back here to the code. So this is just using exactly the same exact code that I was showing you previously, returning a JSON array containing my top 5 items, right? But what I need to do here, in addition to host this code in Azure Function, is to add a little bit of kind of dance here at the beginning, where I'm importing a specific library called Azure Functions. And then I'm importing my database module. At this point, I just need to declare my main function here, which is accepting an HTTP request from my Azure Function module and is returning an HTTP response. As simple as that. And then kind of my main kind of code here is just invoking this DB query method in my other module here, and the query method is just returning the JSON, right? So very, very simple. And in order to load this into Azure Function, in Visual Studio Code, we have an extension which is very straightforward to use. We can deploy this to a function app, and I just need to pick up my Azure Functions in my Azure subscription. Of course, I'm logged into my Azure subscription here, so I can create a new one, or I can use an existing one for simplicity. I just did this a few minutes ago, and basically, once I have this, I can, let me show you this. I have this URL which I created where my Azure function is actually running, and if I execute this, you can see this is returning exactly the same JSON array that I was using previously, right? So very, very simple, but you don't necessarily need to have an Azure subscription in order to develop and run your code here. In fact, what we can do, we have a local Azure function environment that you can deploy in Linux, Windows, Mac OS, and so on. So if I, instead of deploying my function, I'm just, for example, run debugging on my machine, you will see that in a minute, my Azure Function Core tools here are popping up, right? And are giving me a local endpoint on my machine, which is mimicking all the behaviors that we have in the Azure hosted Azure function. And what I can do here is exactly what I can do in my cloud-based Azure function. I can run my queries. I can do whatever I like. And I also have, as you can see here, this is with the Azure function invocation and the trigger that I just created by asking, that URL on my local machine. And you can do all your complete kind of offline development here, and maybe use a local Azure SQL instance running in a local container and such. And then when you're ready, you can deploy everything on the server side or on the cloud side with a few clicks within your preferred kind of code editor or environment of choice, right? So, and I think this is a very powerful option we have. Last but not least, as I was saying, data science. Why data science and why Python for data science? It's a great tool, actually, Python, for data science purposes. We have a lot of libraries, native libraries that are available, even from other languages and kind of other frameworks. It's very helpful because we can use database libraries, we can use scientific computation libraries, all in the same kind of high-level structure that we have. And we have a number of other packages that are providing these data structures that are very capable, very powerful for data analysis, like lists, hash tables, and so on. And if we store our data in Azure SQL, this provides a perfect combination, right? So some of these most commonly used data analysis pipelines are, as you can see here, kind of NumPy, Pandas, and so on. And what you can do, again, I need to rush a little bit because we are out of time, but you can deal with kind of all sort of number calculations and execution. We can plot our results in a kind of visualization mode, and so on. And Pandas is probably one of the most interesting options we have here. I'm just going to show you what we can do quickly on this demo here. And what you can see, this is an example of, sort of a data exploration task where I'm loading data from my Azure SQL database. I'm loading, for example, 10,000 rows here, and then I can play with my Pandas data frames here, and I can do offline calculation, client-side calculation, grouping. We can do all sort of data corrections and data cleansing, and then, for example, just I'm running this example so to give you an idea of what we can do. At the end, we can plot, for example, charts, and if I go back here to my file system, at the end, we can see, for example, we can generate things like histograms and so on and so forth. And we can also do this interactively. As I was saying, we have full support for Python notebooks. So, for example, I have the same code here running in an interactive cell. So at this point in time, I can execute all sort of analysis, and I see my interactive results showing up here in my VS Code environment without kind of leaving my tool, and we can see all the data aggregation and all the data analysis tasks that I was doing previously, right? So very powerful option that we have for data science here. And again, to recap, Python and Azure SQL Database specifically loves Python a lot. We have full coverage for both management and operational capabilities. We have multiple options in Azure to run Python code as serverless functions, as web apps, as kind of other more traditional, microservices, for example, and such. And we can offer the full spectrum of data connection libraries, from low-level stuff like ODBC to high-level ORM tools like SQL Alchemy, Django, and so on. And exploring data within Azure SQL databases with Python and tools like Pandas and Matplotlib and such is very fun. So I definitely recommend you to take a look. You can get more details. We have written a book describing how you can work with Azure SQL database from modern programming languages and platforms. You can take a look at this, or we have a lot of other quick starts in order to help you deal with Python and Azure SQL database. And again, we are slightly over time here. I was trying to see if there are specific questions, but I don't see questions in the Q&A or in the chat. So I think I can end the session here. Thanks a lot for attending this, and I'm available for questions. And just remember, I show you some of the Twitter handles and hashtags at the beginning of the presentation. If you have questions, you can reach out to us over there. Thanks a lot.